And our last question for this topic says, if g of x equals 2x squared plus 5x minus 2, find a g dashed of x, that is the gradient function using first principles, and b the values of x where the gradient is equal to 0. Alright, so let's start off with question A. Now, like always, we need to write out the function. So g dashed of x is equal to 2x squared plus 5x minus 2. Alright, now the formula for differentiating using first principles is g dashed of x is going to equal, as the limit of h approaches 0, equals g of x plus h minus g of x over h. Okay, so first of all, what we need to find out is g of x. So substitute x into g of x. So you get g of x is going to equal 2. Instead of writing x, we write x, so it's the same thing. So you get 2x squared plus 5x minus 2. Right, that's our first part of it. So that ends up having the coordinates x and 2x squared plus 5x minus 2. Alright, the second part of it here. Alright, write out the function once again. G of x is equal to 2x squared plus 5x minus 2. Alright, now we're substituting in x plus h for everywhere that we see an x. So we get g of x plus h is equal to 2 bracket x plus h squared plus 5 bracket x plus h minus 2. Okay, so let's expand that out a little bit. So you get that is equal to 2 x plus h plus 5 x plus h minus 2. Alright, expand that out again. So 2 x squared plus 2xh plus h squared plus 5x plus 5h minus 2. And finally expand this out again. 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2. So then we end up getting the coordinates x plus h for my x coordinate and 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2. Huge coordinate, isn't it? Alright, so now we need to substitute that into our gradient formula that we have right here. Alright, so g dashed of x is our gradient formula, as the limit as h approaches 0 is equal to g of x plus h minus g of x over h. Okay, substitute that in. So g of x plus h ended up being this answer down here. So therefore, the limit as h approaches 0 is equal to g of x plus h, so that is 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2 minus g of x, so in brackets because we're substituting the whole thing in now. So g of x we ended up finding was equal to this, so 2x squared plus 5x minus 2 all over h. Alright, let's expand. So we've got the limit as h approaches 0. So you're going to get 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 2 minus 2x squared. Negative times positive is minus 5x, and negative times negative is positive, so plus 2. How much nicer was that line then? Over h equals the limit as h approaches 0. 2x squared and the negative 2x squared will cancel each other out, as will the 5x and the negative 5x, as will the negative 2 and the positive 2. So we end up with 4xh plus 2h squared plus 5h over h. Now as the limit of h approaches 0, we can factorise the numerator, so you end up getting h at the front, 4x plus 2h plus 5 over h, and of course the h's can cancel out, so the limit as h approaches 0 is equal to 4x plus 2h plus 5. Now as h approaches 0, we just substitute in 0 for this. So the limit as h approaches 0 is equal to 4x plus 2, 0 plus 5. So the limit as h approaches 0 again is equal to 4x plus 5. Therefore, g dashed of x is equal to 4x plus 5. So this here is in fact our gradient function. So this function here actually tells us the gradient of the function that you see up the top, g of x, for any given x value. Alright, so we'll just answer part 2 in this tiny little box. We've got g dash of x is equal to 4x plus 5. Alright, part B says find the values of x where the gradient is equal to 0. Well, what we need to know is that g dashed of x means gradient. G dashed of x equals gradient. Okay, so what it's telling us is actually telling us the gradient. So therefore, g dashed of x is equal to 0. So let's substitute in 0 for g dashed of x. We get 0 is equal to 4x plus 5. Alright, we want to find out the x value where the gradient is 0, so we minus 5 equals 4x, divide by 4, so you get x is equal to negative 5 on 4. Therefore, the gradient equals 0 at x equals negative 5 over 4. Now, when we're dealing with problems that require us to differentiate using first principles, there's actually quite a potential for us to go awry when simplifying expressions, etc. So what I'm going to show you is how to use your calculator efficiently, so that way this problem doesn't occur. So to do this, we need to go add calculator. Okay, and we're going to define the function that we just dealt with, being g of x. So we're going to go menu, actions, define, and we're going to say g of x is equal to 2x squared plus 5x minus 2. Okay, so if I want to find out g of x, so of course I just write g, comma, x, and up it comes with our answer. If I want to find g of x plus h, g of x plus h, it goes through and it simplifies it for us. If, for example, I want to put it into the formula for differentiating using first principles, I go control, divide, so I get my fraction, and I go g of x plus h minus g of x over h. And I end up getting the answer of 4x plus 2h plus 5, which is, of course, what we got before. So this here is a great way, first of all, of checking your answer, but also you don't have to go through and do all of the steps of working out when expanding the brackets. You can just write out this answer that you see here.
Thanks guys, that's all I've got time for today when differentiating using first principles. Now of course, like always, stay tuned for the very next lesson, because the next lesson is all about differentiating by rule. Now, a number of you have probably asked why I've been wearing this on my head the whole time. Well, in fact, it's because I don't actually want you to know what I look like today. Because when you come across the next lesson, where we differentiate by rule, it's going to make everything you've done today a whole lot easier and a whole lot faster, and you're going to absolutely hate me. So of course, like always, say hi to your maths teacher for me. Morsey out.